I'm Vincent Wei from Beijing, China, and I'm very glad to share some ideas about HVM language. It's my honor to take part in this conference. In this presentation, I will talk about the following topics. What's the HVML and special features and interesting features of HVML language, and why we designed HVML, and the benefits we have got and the benefits we will got. And we, at the last slide, I will talk about the current state of HVML community. HVML is my new open source project. It is a try to resolve some problems, and it is the acronym for hybrid virtual markup language. It is very similar like HTML, and it must be a markup language, but it is dynamic and programmable, and it is a descriptive programming language. It is driven by data and events inherited, and the HVM program outputs data and a structured document. This is the main difference between HVM and other programming language. The picture in this slide is the logo of HVML. It is called a purring cat. Okay, let's move to the next slide to see some special features of HVML. We use modified markup syntax to write an HVML program, and we use extended JSON notation to define data, attribute values, and expressions. HVML introduced a dozen of web tags, along with preposition attributes and the verb attributes. We can easily define the operation and the program structure. This slide gives the two versions of Hello World in HVML. The first one is almost the same like other languages such as C or Java. So I pass it quickly and move to the next HVML program. This program show that we can generate a structured document such as in HTML. So you can see many tags in the program such as head, title, body, P, but you can also see another tag different from the ones of HTML, iterate. Obviously, iterate defines a loop on an array. It consists of three numbers, 0, 1, and 2. Obviously, this HVML program will generate a HTML document with 3 P elements. We call HVML is a descriptive programming language because we use verb, tags, and preposition attributes and the verb attributes to define an operation, such as we can init an empty array, just like some simple words, and we can initialize an array variable from an object array by using the JSON notation to define the object array. And we can use uniquely the verb attributes to define a set variable. and the property ID will have unique values. And if there are any duplicated values, such as 2, 2, 2, if we use silently attribute, this operation will ignore any data that break the data consistency. And in the fourth init elements, we can see that the operation try to get data from a remote URL. And you can schedule the task run asynchronously. So this gives a very important features descriptive language. It is very easy to understand and very easy to write, and we can give many flexibility to your application, to your program. Now let's move to the next slide, and this shows the data-driven and event-driven feature of HVML. If we try to get data from a remote URL asynchronously, like this element, we can use an observe element to wait or listen for a specific event. In this case, it is change attached. So if the data received by your HVML program, the programmer will got an event called change attached and bounded with the users. After this, the operation defined by the observe element will be executed. This is the event driver of HVML program. The next HVML fragment shows another feature, which is called data driven. In HVML, we define many predefined objects, such as timers. It represents all timers created by current HVML programs. It is empty at the initial stage. But if we update the data to append a new object, it defines the identifier, the interval, and the active status of a timer. If it is active, and you will got a new timer event when the timer expired. That is, we can change the system function by change the data instead of to calling some method on a object. This is another example in HVML. We call it data driven. Because HVML mainly used to operate the DOM, so it has many features as other language or technologies to do the same thing. For example, Angular and Vue. So it also provide data templates or document templates, and we also can use HVML templates to handle exceptions, and we can easily to create closure by using HVML. So let's take a quick glance for the other features and move to the next interesting features of HVML. I will introduce 4 interesting features of HVML. The first one is called compound expression. If you familiar with bash shell, you can see that that the compound expressions is come from the bash shell. We can join multiple expressions by using AND operation or semicolon or operation, and this compound expression can be used to define attribute, value, or element contents. So, but it has a simple logical control logical flow control. The next interesting feature of HVML is operation group and executing in place. Actually, operation groups you have seen in the observed element. It is defined by the observed element. We call it operation groups. Generally, we can use define to define operation groups. For example, it can be used as a function in C or Java or JavaScript. So we can use core to call this operation group. We do not use the term function, because of in HVML we treat one element as a function. So we use the operation group for the operations element or elements defined by the defined elements. And the interesting features is the executing in place. Core is very similar with the other application core function and get the result of the function. But if we use include, we can got another effect from the element. This just like we copied the operation groups from the define to the position of include elements at. That is, it is a very interesting features. And the third interesting feature is coroutines. HVML provides support for coroutines with the special manners. We can use load to load another entry of the current HVML program or another HVML program, and this will start another coroutine to run the HVML programs, and we can schedule the coroutine run synchronously, and we can observe the exist status and to handle the event to. For example, in this sample, the parent start children coroutine and sleep for 5 seconds. The children coroutine start a timer and print a line every second. After 5 seconds, it exists, and the parent got the exist status of the children and the parent coroutine back. The last interesting features of HVML is runners and concurrence. In HVM term, runner corresponds to a thread in the HVML interpret instance. We can call a function and schedule the function to run in within a new runner, and in this way, the function will the operation group will run concurrently, and you can schedule to run it synchronously. And after this, we observe on the task and wait for the specific event. For example, call state success. And also we can use load to do the same thing and observe on the coroutine for the call state observing. And we can send request to the another coroutine and wait for the response from it. The last interesting features of HVML is substitute expressions. We use bind to define substitute expressions. If you have a very complex experience, but we can give it a new name and a new property. After this, we can use this new name and the new property to access the older original experience and pass the parent to it. By this way, we can get a very interesting feature, and we can use constantly attributes in the bind element. In this way, we can improve the performance dramatically, because of some computer or evaluation of experience will give the same result. In this case, we just evaluate the experience once, so that we can get a new, very good improvement on performance. So why we design HVML? The original design goal of HVML is to allow developers who are familiar with C or C++, Python, or other programming language to easily develop GUI application by using web technologies such as HTML, SVG, DOM, and CSS, instead of using JavaScript programming language in a web browser or Node.js, because I am a C and C++ program. We waste a lot of time to tune the styles and the layouts of GUIs when using the traditional C and C++ toolkits like MiniGUI and GDK OQT. And there was no way to utilize the modern web technologies directly in C and C++ environment. This is very disappointing for me. And we noticed that there are some disadvantages of web technologies. For example, the user experience of web pages are always worse than the native web GUIs, because it is very slow to update DOM. And the JavaScript engine and the web page renderer always compete for the processor. This leads to the jams of interaction. And it is difficult to manage multiple windows by using web technologies. And the HTTP protocol is stateless. JavaScript engine always runs in the browser. It is hard to write JS extension. So we decided to design a new language to give a new solution for the C and the C++ program to utilize the web technologies. After the implementation of the HVML interpreter and the renderer, we got some benefits. For example, we can now use HVML to rapidly develop GUI applications based on web technology, such as we can use we can develop a GUI application by using HTML, SVG, DOM, CSS. This is, in the past, we can only use it in a web browser. We got a cross-platform HVML interpret. We call it PERC. And we now use HVML as a general purpose programming language to write scripting tools. And we got a stack-based virtual machine to run HVML program. And we got a solution to decouple the interpreter and the renderer. And we got flexible cross and app frameworks. So we, in the next slides, I will introduce in detail about the virtual machine and the decoupling and the cross and app frameworks. The stack-based virtual machine, we use a stack-based virtual machine to run HVML programs because we use a virtual DOM tree to represent an HVML program. The interpreter creates a new stack for every new HVML program instance, that is coroutine. The interpreter executes every element of VDOM from the root element in depth first order. When the depth increments, there will be a new stack frame on the stack, and the interpreter stores the context data in the stack frame. When the depth decrements, the interpreter pops the stack frame and tries to execute the next sibling element. All foreign elements in an HVML program have the universal operation, clone the attributes and the contents to the current position of the target document. In this way, the foreign elements and the HVML elements can be mixed in an HVML program. That's very interesting because we have a stack-based virtual machine to run the HVML program. To run the HVML, to support the data drive and event drive, we define 4 executing stages of an HVML coroutine. It is scheduled, first run, observing, clean up. First run, it will all ignore any observe and define. It's just make some, create some observer and just to do something. But when after the first run, it will enter the observing stage. The coroutine waits for the event and handle them, and the coroutine enter the event loop. In HVML framework, we decouple the interpreter and the renderer. We use virtual DOM to avoid updating DOM frequently. This is a general solution to improve the render efficiency of the browser, such as mini programming in Beijing and Angular and Vue. This solution all use the virtual DOM. So HVML use this also. But HVML introduced the decoupling of interpreter and the renderer. So interpreter and the renderer no longer compete for the processor. The interpreter and the renderer can be different threads, all different processes, all different machines. This provides the flexibility of the framework. And we can easily manage multiple windows by using HVML. And the HVML program is stateful. It is not stateless. Now, in this slide, we will show you some frameworks of HVML. We call this is cross and app frameworks. The first gives the a minimal framework. In this situation, the renderer runs in a thread as a runner with other HVML runners. So it can share some data or the target document. So it will give the best performance, but it has the other disadvantages, such as it's not flexible, but it can be used embedded system or a smart IoT devices. The next, the renderer. Okay, what?
You need to finish your talk in 3 minutes.
Okay.
Yeah.
Okay. Oh,
okay.
Okay. Let's say this is renderer. This frameworks run the renderer server, and the interpreter connect to the server as a clients. And this is connect the renderer and the interpreters via a data bus. In this frameworks, the interpreter runs in the cloud and the renderer runs on clients. This is a simple. The target document will be dumped or just discarded. Okay, the benefits we will get in the future, we will unify CLI and GUI development. CLI means the command line interface. We may get a web server written in HVML, and we will get some decentralized deployment of HVML applications. And in the last slide, I will talk about the current state of HVML community. After 1 year's development, we opened the following repository in July this year, include HVML specification, interpreter, and graphics renderer XGUI Pro, and a tailored web kit. And the standard, we have no many developers, 3 engineers, and 10 contributors, and we got 1,000 stars on GitHub, and we totally have 100 million lines of code, and so on. We are actively developed HVML. About next March, we will release the first official release of PERC. It will implement all features defined by HVML specifications, and it will support Linux, macOS, and Windows. Okay, that's all. Thanks for anyone for your times. Any question?